Okay, finally, this is lesson 8.4. My apologies for it going up so late, but it's finally here. Thanks for watching. And what we're going to be talking about today is writing rules for linear functions. Okay, well, first let's talk about notation. There's two different notations that you'll see for a linear function. Okay, so a linear function is basically of the form 2x plus 3. And we've already talked a little bit in class about how the number that is multiplied by the x serves as the slope. We can identify it from an equation by whatever number is times the x. And the second number, the one that's by itself that doesn't have an x, is the y-intercept. Okay, and we talked about how to use these numbers to go ahead and to graph a function. All right, now this can be equal to one of two different notations. Okay, sometimes you'll just see it equal to y. Okay, and that's a very good notation. Find the value of y when x equals a certain number is a very common problem that you'll have. So if I say find the value of y when x equals 5, you would put 5 in. 2 times 5 would be 10. We'd add 3 and we get 13. So the y comes out to be 13. The only problem with that notation is I would literally have to write a question that says find the value of y when x equals 5. A slightly more efficient shortcut notation is to call the function, instead of calling it y, call it f of x. Okay, and that's exactly the same thing. You can see that I'm putting these together because basically the y and the f of x are going to serve the exact same purpose. Okay, when I graph y equals f of x, this would be the x axis, and this would be the f of x axis, which is the same thing as the y. Okay. The difference here is now, instead of having to say the words, find the value of y when x equals 5, in this case, I can just say find f of 5, which means the same thing. It means put 5 into the function for the x values, evaluate using order of operations, PEMDAS, and figure out what value you get. So there's two different notations, so let's just clear that up right away. The first notation, it's usually just called the y equals mx plus b, slope-intercept form. The second notation is called a function notation. And again, it only works if something is a function, meaning that for each x, there is exactly one y. All right, the next kind of problem that you might have to write a function for would be a word problem. Okay, so suppose that I order shirts, and the shirts are going to cost $12 a piece. But I also have to pay a shipping and handling fee of $5 per order. Okay, and it doesn't matter how many shirts I order. So if I only order one, can't spell today. If I only order one shirt, I would pay $12 plus $5 in shipping and handling, so it costs $17. On the other hand, suppose I order 10 shirts. Well, 10 shirts times 12 would be $120, and then I would just tack on $5 more. So the shipping, actually, the more shirts we order, the less per shirt that we're paying to ship. Okay, so let's go ahead and let's define some variables. So let's let C equal the cost of my shirts. That's going to be like the y value. And let's let the variable S, and notice I used a script S, because if I use a regular S, it might look a lot like a 5. And that's going to be how many shirts I buy. And that's all you got to say. If you want to write out how many shirts I buy, that's fine. You could see could be the total cost for the order. But here's going to be the equation. All right, we already said we kind of figured this out when we were doing the 10 shirts. We're going to take $12 and we're going to multiply it times the number of shirts, right? So if I get 3 shirts, 3 times 12 would give me $36. I'm then one time going to add the $5 per order, okay? And so here's the equation of the cost of the shirts. Now, you could say that the cost per shirt is acting like the slope, and it is, and you could say that the shipping costs that we add, regardless of how many shirts I ordered, are kind of like the y-intercept, and they are. The little funny thing about this equation is, what if I ordered 0 shirts? Well, it doesn't necessarily make sense, but according to this formula, it would still cost me $5 shipping and handling. Now, that's not a very real-life example, but again, if you put in any number of shirts, by the way, I could do this as a function notation. C of S will say find the cost of S shirts, and I just plug the number in for S, put it in here, and put it in there, multiply by 12, add 5, and I will get the answer. Okay? The next way to get a function will be if somebody draws a graph. and you have a line drawn on the graph, and you can look at the graph and you can see that right here at -3, the graph across, so that's the y-intercept, the b. And then what you do is you pick a point here, and maybe pick a point that's up a little higher, and maybe we've gone up 3 units, and we've gone right 4 units. Okay, which means my slope, don't forget, it's the rise over the run, the delta y over the delta x. So the rise here was up 3 units, so that's a +3, and the run to the right is a +4, so the slope here is 3/4. Put those two things together, and I've got an equation. Y is equal to 3/4 x minus 3. Or I could say f of x is equal to 3/4 x, 3/4 times x, minus 3. The last and probably the hardest way to come up with a function is when you have a table of values. Let's say you have an x and y value, okay? And let's say you have the values -1, -2, and let's just go down the x's. We'll go -1, 0, 1, and 2. We might as well put a 3 there too. And let's say the x's are -2, 0, 2, 4, and 6. All right, well, the first thing you look for is you look for where x is equal to 0, because that tells you the y value when you cross the y-axis. So this right here, so look for x equals 0, and whatever number you have here is your y-intercept. So this one's going to actually cross at 0, 0. That's a special point. Remember, that's called the origin. Okay, and then what you're going to do is you're going to figure out the slope. And the way you do that is you look at the difference from one line to the next, and you can see that in each case my x's are going up nice and even. They're all going up by 1s, right? But the y's are going up evenly, but they're going up by 2s. Agreed? All right, again, delta y, the change in the y, over the change in the x. So we're going to start on the right, so the change in the y is 2, and the change in the x is 1. So 2 over 1, the slope is 2. So now I put these two pieces together. The b is going to be 0, the slope is going to be 2, and if I write that as y equals 2x. Now, plus 0, I could put that, or since plus 0 doesn't actually do anything, I could just say y equals 2x. And that will be the equation for this line. And we're going to go through these. Now, for the ones that you're going to have to do, they're always going to give you an x value of 0 somewhere in your chart. So they're going to basically tell you the y-intercept. Now, there is another way to do it where they don't do that, but we're going to do, I'll save that one for class. I want to keep this video short. So thanks for watching. This is Mr. Gunn signing off, and thanks for watching. I'll see you in class tomorrow.